Hi students, let us start with the new chapter electricity. In this session, we will learn about electric current and circuit. What is electric current? Electric current is the rate of flow of electric charges. Rate of means divided by time. Flow of electric charges. Electric charge is represented using the letter Q, and you use capital letter I to represent the electric current. Therefore, electric current I is equal to Q by T. I is equal to Q by T. You might have learned the atomic structure. According to Bohr model of atom, the nucleus is at the center and electrons are revolving round the nucleus. You know that this nucleus contains protons and neutrons, where protons are positively charged particles and neutrons have no charge. Electrons are negatively charged particles and they are revolving around the nucleus. These electrons are moving around the nucleus. Therefore, when I say flow of electric charges, it is the flow of these electrons. This nucleus is stationary. Only the electrons are moving around the nucleus. Or otherwise you can say electric current is the flow of electrons. What is electric charge? Electric charge is Q. Q is equal to Ne, where N is the number of electrons and E is the charge of an electron. This electric charge is measured in coulombs, represented by capital C. The charge of an electron is 1.6 into 10 raised to minus 19 coulomb. This is negatively charged. If this charge Q is 1 coulomb, what will be the number of electrons present? E is 1.6 into 10 raised to minus 19. N is equal to Q by E, because Q is equal to Ne. N is equal to Q by E, where Q is equal to 1 and E is equal to 1.6 into 10 raised to minus 19. This is equal to 6.25 into 10 raised to 18 electrons. The number of electrons for 1 coulomb of charge is 6.25 into 10 raised to 18. SI unit of charge is coulomb. Charge on an electron is 1.6 into 10 raised to minus 19 coulomb. N is equal to Q by E, which is equal to 6.25 into 10 raised to 18. Therefore, 1 coulomb is equal to charge carried by 6.25 into 10 raised to 18 electrons. Electric current I is equal to Q by T, where Q is the electric charge, which is a scalar quantity. Therefore, electric current is also a scalar quantity. In the expression I is equal to Q by T, Q is measured using the coulombs and I, electric current, is measured using the amperes, represented by capital A. SI unit of current is ampere and current is a scalar quantity. We know the expression I is equal to Q by T. Then how will you define 1 ampere? This electric current must be 1 ampere. 1 ampere means this Q must be 1 and T must be 1 if you want this side to be 1. Therefore, 1 ampere should be 1 coulomb by 1 second. How can you define 1 ampere? 1 ampere is the current which flows in a conductor when 1 coulomb of charge passes in 1 second. 1 ampere is equal to 1 coulomb per 1 second. The smaller units of current are milliampere and microampere. 1 milliampere, it is represented using the letter small m and capital A. That will be 10 raised to minus 3 ampere. Microampere is represented using the symbol. This is the symbol for micro. Microampere is 10 raised to minus 6 amperes. When you see this symbol micro, it will be always 10 raised to minus 6. Milli, it will be 10 raised to minus 3. This milliampere and microamperes are the smaller units to measure current. Continuous and closed path of an electric current is known as electric circuit. This is the diagram of an electric circuit. This electric circuit consists of a battery, an electric bulb, ammeter and a plug key. Conventionally, the electric current flows from the positive terminal of the battery. This is the direction of the electric current. You can see from the diagram, it is a closed path. It is starting from this positive terminal. It goes in this way and it comes back to the negative terminal of the battery. This plug key is the closed switch and this indicates ammeter. Ammeter is an instrument which you use to measure electric current in a circuit. This is the symbol for an electric bulb. As you can see from this electric circuit, it is a continuous and closed path. What do you mean by conventional current flow and electron flow? For a conventional current flow, look at this diagram. This is the positive terminal of the battery and this small line represents the negative terminal of the battery. The current is flowing from the positive terminal towards the negative terminal. This is the conventional current flow. Then what is electron flow? Electron flow is actually the opposite way. The electrons flows from the negative terminal like this towards the positive terminal of the battery. This is the electron flow. But still we follow this conventional current flow. To draw the circuit diagrams, you have to learn the symbols. For an electric cell, you can represent using this symbol. One big line which indicates the positive terminal and small line indicates the negative terminal. For an electric cell, you can use this one. If you draw more than one cell, you will call that as a battery. This is the positive terminal and this is the negative terminal of the battery. For an electric bulb, you can use this symbol or this symbol. The symbols for plug key or open switch is in this way. If you put a dot inside, then that plug key becomes a closed switch. This represents a closed switch and this represents an open switch. This symbol is for a wire joint and for a wire crossing without joint. This is for a resistor. A variable resistor can be represented using this symbol, or you can draw like this. This shows that this resistance is variable. For an ammeter, you can represent using this symbol where this is positive terminal and this is negative. For a voltmeter, you can use this symbol. Ammeter is used to measure the current in the electric circuit and voltmeter is used to measure the voltage in that circuit. In this session, we learn about electric current I. I is equal to Q by T. It is the rate of flow of electric charges. Electric current is measured using amperes and electric charge is measured using Coulomb. I is equal to Q by T. For 1 ampere current, the charge must be 1 Coulomb and time must be 1 second. If this electric current flows in a continuous and closed path, then you will say that as an electric circuit. The conventional current flow is always from the positive terminal to the negative terminal, whereas the electrons are actually flowing from the negative terminal to the positive terminal. Also, we learn some of the symbols of components which you are using in circuit diagrams. I hope you understood this session. See you in the next class.